We turn now to another example involving the expression square root of 1 minus x squared, except that we're going to do it in a little bit of a different context so that the answer doesn't come out to something familiar. So first of all, we're going to perform the same substitution for the same reason, because for the reasons expressed in the last example, when we have an expression of this form, we want to use the substitution x equals sine theta, which leads to dx equals cosine theta d theta. And one thing to note also, by the way, is you can write this out. It's often useful to write out the value of the square root expression itself. So note that square root of 1 minus x squared is going to be 1 minus square root of 1 minus sine squared theta, which, write that a little neater, which is equal to the square root of cosine squared theta, which is equal to cosine theta. So we can now write is that the integral of the square root of 1 minus x squared dx is equal to integral of cosine theta times cosine theta d theta. Notice where all of this comes from. This is just the square root of 1 minus x squared, and this is dx. So everything that was in the original integral maps onto something in the new integral. And this is now the integral of cosine squared theta d theta. So we now need to find the integral of cosine squared theta d theta, and you now know why we've spent time in the previous section finding integrals of powers of trig functions. So there are a couple of ways that you can do this. I'll do it the more traditional way. So let me just zip through the algebra here. Okay, so we now have the antiderivative of cosine squared theta, which is 1/2 theta plus 1/2 sine theta cosine theta. So what we need to do now is do the back substitution. We already saw how we can substitute, how we would be able to substitute sine theta because we already let x equal sine theta. The problem is we don't have an expression for either cosine theta or theta itself. So the way we do that, get a little more space here, is what you want to do is draw a triangle. Remember that all trig expressions have to do with right triangles. So what I'm going to do is draw a right triangle that obeys the relationships given in the original in the original substitution, x equals sine theta. So if x equals sine theta, and then keep in mind that we know that sine of theta is equal to the opposite over the hypotenuse. So what I want to do is draw a right triangle where the ratio of the side opposite theta to the length of the hypotenuse is x. The simplest triangle that has that relationship has an opposite side of x and a hypotenuse of 1, and then by the Pythagorean theorem, that gives us the adjacent side is the square root of 1 minus x squared. So we now have everything that we need to do the final substitution here. So first of all, let's do theta itself. So theta, since x equals sine theta, that means that theta is equal, well actually let me write all that out. If x equals sine theta, then for the reasons discussed last time, that means that theta is equal to arc sine of x. Okay, so we have in the answer, since I need to get that part of it, it's going to be 1/2 arc sine of x, and then plus 1/2 sine of theta, we already know is x, and cosine of theta is going to be the adjacent over the hypotenuse. So that's the adjacent side, and that's the hypotenuse. So that's going to be x square root of 1 minus x squared. So we now have the antiderivative, or an antiderivative. We do the hardest part of the problem, the plus c, and we're done.